Okay, hi everybody, and thank you to Andy and Matt and anyone else who helped organize this. I'll be talking today about iterators, a relatively new Go feature, and how they interact with error handling. I have the heartbreak because I don't think they interact very well. I'm going to talk about the problems that came up as I was building this program that I built and released open source recently called GitWho. Who am I? I'm a backend engineer at a company called Chirpbeat. I'm also a relatively new Go user. As I said, our company does not use Go, so I'm just learning Go for funsies. And I really built GitHoo just because I wanted to build something substantial in Go. I'm not an expert, so this is really more like problems I encountered in case you encounter them too. I don't really know the solution, but it wasn't obvious to me. I do know a few things not to do, so that's what I'll talk about in this talk. To kind of set the stage, if anybody knows anything about Go, people know that a lot of people don't like the error handling. So on Hacker News, this guy, this guy Deagle50 says, worst part of Go. Bad Jelly Bean says it is incredibly annoying to add these check blocks. Andy Royd says they should have just named it Erlang. I agree. I actually quite like the error handling in Go. Especially coming from Python. I like that it's so explicit. But I have to say, I liked it less when I was trying to use it with iterators. So what happened? Why did my interest in error handling kind of wane? I think one problem is that there's not a lot of guidance on how to do error handling while also using iterators. This is the blog post that was released last year when iterators landed in Go. There's no mention in the blog post of error handling, so it's just like, here are iterators, figure it out. And especially as someone coming to Go for the first time, I really just had no idea how I was expected to do it. So mostly this talk is about kind of what I figured out for myself. Like I mentioned before, some of the problems I ran into. But before we get to that, I'm just going to talk quickly about GitWho, what it does, and why I wanted to use iterators. And then I'll briefly go through iterators just because people may not know exactly how they work in Go since it's a new feature. I'm going to stop for questions after each section. Okay, what is GitWho? The kind of best short tagline I could come up with was kind of git blame for file trees. The idea is with git blame, you can see for each line in a file who most recently changed that line, and that gives you some sense of authorship. But if you wanted to try to figure out like, okay, who is substantially responsible for this file, there's not really a great way to do it. You could kind of look at git blame for the whole file and like, oh, this person changed most of the lines. That's one way to do it. But I didn't really like meet my use case. What I really wanted was a tool where I could like, okay, look at a large code base and figure out, okay, who like owns which part of the code base, who has contributed most to this file or like this component. And so that's what I built GitWho to do. I think it's really useful for getting like context on code as well. I've often had this experience where I'm reading some code and it seems to be written in some very idiosyncratic style. And then I can use GitWho to see like, oh, okay, like Bob wrote most of this code. That's why everything is written in this very idiosyncratic way. That's just how Bob likes to do things. So that's the intention behind GitWho. GitWho is just a command line tool. It's got 3 subcommands that I'll walk through very quickly. This is kind of the standard view. It's the default subcommand that's kind of implicit. This is the table subcommand. And so this example I'm showing here, this is for the CPython Git repository. This is showing the top 10 contributors, in this case, ordered by lines changed over the whole history of the Python project. You can order it by a bunch of different metrics. The -L is lines changed. This might be a little small to see. I'll blow it up a bit, but this is a second subcommand called tree, which allows you to print out kind of in more granular detail the files in a repository or perhaps under some subpath and see who has changed the most. And then finally, there's this last subcommand, git who hist, which kind of prints out like this historical timeline showing for each year, who is the top contributor to that file or that set of files, a way to see, okay, over time, how has like responsibility for this file or component changed? And then you can, filter by various things. Okay, to get a little bit into the underlying design and why iterators are useful, this is kind of a high level view of the operations that are happening. I really wanted GitHoo to be fast, even on repositories with a very large commit history. So I tried to leverage Go's built-in concurrency. This was great. Thumbs up for Go. I'm not saying Go is a terrible language. I really enjoyed this part of it. The problem came in when I was using iterators. The reason I wanted to use iterators and GitHoo, why I reached for them after learning about them, is that fundamentally GitHoo is like reading commits from Git log, which I'm running as a sub process. And then all of these different subcommands are aggregating metrics derived from the commit log in different ways. And so I wanted some uniform interface to the output of Git log that I could use across my program. And that's where the iterators came in. Any questions about that so far?
So if I'm at the directory level, the third file in the directory has an error, whatever reason. I try to understand what do you want the error to do? Like,
When you say error, you mean the file has.
let's say for this reason, like that file failed. So iterating through 10 files, the third one. So what do you scan at that direction? Your goal.
Okay, so you're jumping ahead a little bit to if we're iterating through all of the files and we get an error.
You're finding a bunch of elements together, right? So like,
Yes.
How do you model that?
In terms of the error handling, I'll get into it a little bit. I think maybe if you're asking like, what do we do with the error? I think that's a fair question. In this case, I really just want to output a very informative error message to the user. This is not like an incredibly complicated system. Like you just run it once. We don't have to worry about it like living over time. But I did want to know like where the error happened and output some useful information to the user. So the question, yeah, is then like, okay, if we encounter an error during this whole process, like how do we surface it? Yes, we would probably, yeah, in most cases, we would just abort and say, this error happened, and here's this information about the error. Any other questions? Okay, moving on. Have many people used iterators in their Go code all? Okay, one hand. Okay, so relatively new feature, that's great. Okay. So they were introduced in Go 1.23, which was released last year. What is an iterator? It's really a very kind of abstract design pattern. It exists in a lot of different programming languages. It's not something specific to Go. One way to define it, the definition given here in this talk from the GopherCon last year, where they introduced this feature, an iterator is just a way, like an abstract way to provide access to a sequence of elements, but the key is kind of abstract, like the underlying representation is still hidden. So some analogs in other languages, Python has this iterator protocol. C# has these two interfaces, IEnumerable, IEnumerator, and then Rust has an iterator trait. So this is very common in a lot of programming languages. Go is a little different in that rather than being implemented as like an interface of some kind, iterators are just a specific kind of function with like a particular function signature. That's why you might see them sometimes referred to as like range over function types. which is a bit of a mouthful, kind of alternative way of describing what an iterator is. So Go is a bit of an outlier here. Uh, Hopefully this is large enough to see, but this is the function signature for iterators in Go. There are two kinds of iterators. There's an iterator over like a sequence of single values. That's the one at the top there. And then there's an iterator over pairs of values, like two tuples. Um, an iterator is just a function that takes another function as an argument. So it's kind of complicated to parse, but it is just a function. And then the function it takes is conventionally called yield. And in the first case, for just the single values, yield takes a single value. In the second case, it takes two values, and then it returns a Boolean. And what the Boolean does, is it indicates whether the iteration should continue. So if the yield returns true, I believe, it continues. If it returns false, then the iteration stops. So what would this look like? If you were to create the iterator, it really is just a function. So in this case, I'm just creating a function that matches this like pattern. And all this iterator does is returns the integers from 1 to 10 in a sequence. And you can see that in the range loop, I'm calling yield repeatedly. And then if it returns false, I end the iteration. So it's just a function that matches this signature. And then what does it look like if you consume it? There are two different patterns for consuming an iterator in Go. Probably the more common one, this push iterator pattern, is just you use like the range keyword to iterate over it. That's very straightforward. There are some few cases where that doesn't really suffice for something you might be doing, particularly if you're trying to like interleave two iterators. You might need to do this second pattern called the like pull pattern, which is a little fancier, but basically it's just like a different way to perform the iteration. Okay, any questions about iterators?
Your previous step said range over 10. So would it return false? Yes. And I never used like iterators.
Yeah.
Function go here, like I put the last element, or should it basically say, hey,
Yeah, I think it's like you might stop for two reasons, right? So as you're saying, you might stop because you've run out of elements in the sequence, in which case you just get to the end of the function and it returns, and that's the end of the iteration. The yield thing is really about what the caller wants to happen. So the caller is like iterating through here, but for some reason or another, the caller might decide, I don't want to iterate through the rest of the sequence. Maybe there are still elements left. The returning false is the way for the caller to say like, stop, like I don't want the rest of it, even if there might be more. Does that answer your question? Okay, sure. So when yield, when would it be false? So it would be false here if you're consuming it when you call stop. So in this like second thing here where you like, basically it's the Go runtime or the Go compiler that is inserting that return false. And it happens behind the scenes. It kind of more obvious in this second example where you call stop. That's when it will return false. In this first example, a lot more is hidden behind this range keyword. And I don't know exactly when it would call false, but presumably when maybe when there's like a break statement inside of your range, your for range loop. Any other questions? Okay. And then this last section actually is going to be a bunch of code. So stop me at any time if you've got a question about some of the code on screen. Okay, so we've got this program I wrote. We've got iterators and error handling. This is kind of a walkthrough of like the disasters I encountered trying to use both of these in building my program. This is like the happy case. So I'm pretending here that we're iterating over commits, and my like pretend imaginary commit sequence is just like a slice of strings here where each string, sort of looks like a commit hash. So that's going to be our example. In this case, this function commits returns this iterator over all of the strings, all of the slices, or sorry, all of the strings in the slices. So this looks very similar to what we've seen. And then in our main function, we just iterate over all of the commits and print out the string. So in the absence of errors, this is kind of straightforward. Obviously overkill if you just really had a slice of strings, but we're pretending that we're like reading these commits from like a sub process running git log. So the question is, okay, if we encounter an error, like how do we communicate that back to the main function? Sorry, do you have a question?
Why don't you have like a richer object instead of string at line 11?
So in the real program, I did have a richer object representing a commit and all the data that might be associated with a commit. Here, just for illustration, I'm using a string. Okay, so you can imagine that maybe we encounter some error like on line 13, which is blank here, but like maybe we encounter an error there before we're like setting up the iterator. If that's the case, it seems like we could just handle that the way we'd normally handle an error. Like you would just add a second return value to this function commits, returning the error. That's kind of straightforward. But then the question is really like, okay, if we encounter an error like in there where we're iterating through all of the commits, how do we handle that? In this case, we're just reading strings out of a slice, but like in reality, we could be parsing the output of git log and trying to turn that into our rich commit object. We might encounter an error then. We could just panic. That's not very helpful. We don't want to do that, even though some other languages, that's kind of how they approach errors. We really want to return a value to the caller. So say we want to do that. Maybe we like, okay, we're going to have this error that returns from commits. We're going to check it in our main function. And then of course, like, okay, we encounter an error, which I'm representing here is like, okay, we find some commit hash that's all zeros, like that represents a parse error. Like see, we encounter that parse error, we set up the error. Is this going to work?
So the issue is that you're handing the values back to your user.
Yes.
In this case, line 7 is a value 100 to hand back. So what I would have expected is that handing the error using yield. So yield should take either a good result or a bad result. One protected by some sort of basic intent union.
Yeah.
Like whatever you want to do, but basically a thing that you're trying to do is you're trying to give the consumer result. In this case, the result is error.
Yes.
So yeah, line 7 should be.
Yes, you've got the right idea.
Okay.
We're going to move on to something that looks a lot more like that.
Okay.
But just for now, this is something, I don't know, somebody trying to do this for the first time might be like, hey, I'm supposed to return errors from functions. I've got a function creating an iterator. I'm countering an error. I want to return it. This code sort of seems plausible, but like anybody else see like a critical problem with it?
iterate this. So when this gets returned, setting the error inside of this does error the call.
Yeah, that's exactly right. So if you try to run this, even though it is always encountering the error, because we've set up that slice that way, we actually never see this error message printed to the screen. And it's not so easy to see why that is, but really the problem is when we run the commit function, it will always return nil on line 15 as the value of the error. And then the variable called error on line 19 will always be nil. And then during the iteration, we set error to this other thing. But by that point, like that error variable is like just hanging around attached to this closure, but it's no longer got any relationship with the error variable on line 19. So this doesn't work, even though it does compile. Question?
Just curious, just read from that.
Return an error channel. Yes, I hadn't considered that, but that could work. Basically, my other proposal here is like somewhat similar to the channel. Basically, you have some other way to like pass this information back through. In this case, I'm just using like an error pointer now. It's like, okay, while we're running the function, we can like set the error pointer to something and then later check the variable, the value that is stored in that pointer. So this actually does work, but also just seems kind of strange and not very idiomatic. It also leads to some other problems. So in a lot of other languages, there's this concept of an iterator adapter, which is basically an iterator that takes other iterators and returns a new iterator. So in this case, I've got this like cute little thing called every other, which is basically consuming an iterator and then returning every other value in the sequence. And these are really nice. They're very flexible. It allows you to like compose like a chain of operations in this really fun way. But having this approach to error handling makes it very difficult to compose these things. And what we'd really like to do is like call every other and like immediately wrap it around commits, but we have all this like extra stuff to worry about with this error pointer. And that just seems kind of crazy. So this doesn't seem like a great approach. A better approach, this is starting to get closer to what you were suggesting. So if you remember when I talked about iterators in Go, there are two kind of classes of iterators. There's this single value iterator, and then there's this two tuple iterator for iterating over multiple like pairs of values. So one option is, okay, this iterator could be an iterator over string error pairs. And that way, if we encounter an error, we can yield that error as a value in our sequence. When we don't have an error, we just yield the commit and then a nil error. And one benefit here is that it does make the iterator more adaptable, or sorry, more composable. You can write these iterator adapters. One weird thing is that the standard library doesn't really seem to anticipate this use case. Very few methods, like there are these nice methods in the slices package that allow you to turn a slice into an iterator and vice versa. But there's no equivalent for this like iter.seek2. So I had to write my own version of those functions basically. So it's a little strange that it doesn't really seem anticipated. Okay, I think this starts to get really spicy when you have like some cleanup logic that you want to run after your iterator. And then the question is, okay, what if that cleanup logic involves something like waiting for a subprocess to exit? That might produce an error, in which case, okay, how do you return that error to the caller? It seems really like a problem. So here, for example, we might, after our iteration, call wait and then return that error as an error that can come from commits. This code, sort of like the code we we're looking at before, kind of like on its surface looks okay, but there's a major problem here as well. Can anyone tell me what it is? So remember, we're reading these commits, and here it's just in a slice, but we're reading the commits conceptually like out of a subprocess. And so, here we're going through the commits, but then down here, we're waiting for the subprocess to exit. Sorry, do you have it? Exactly. So what's happening on line 9 is we're creating this function that will later be used to iterate through the sequence, will later be used to read values out of the subprocess. But then on line 23, before that's been used at all, we're waiting for the subprocess to exit. So this actually doesn't make any sense, even though on its face it kind of looks okay. So we can't handle errors and cleanup after the iterator this way. That doesn't work. Another option would be to go back to this approach of like, okay, we're going to try to like yield the errors kind of in the sequence. But the awkward thing here is like, okay, we've actually yielded all of the sequences, like all of the elements in our sequence already. Maybe we can like add on like a little extra element at the end for potentially this cleanup error. So now I've moved this wait like into the iterator function. It's just happening after we complete the like for loop over the slices, over the slice of commits. So in this case, we're always yielding like the 0 value for a string and then the error if there was one. Can anyone think of a problem with this? Okay, you asked earlier about like, what if yield returns false? Like what if the caller exits early and doesn't consume all of the values in the sequence? Like that's definitely something that could happen. So here's a case of someone using that like pull style of iteration where it's kind of more obvious when they might stop. This code, basically someone is like iterating through this list of commits. They actually only care about this commit ABC123. As soon as they see it, they like exit and they don't consume the rest of the sequence. So they actually never get a chance to see that last element, which had the error on cleanup. So that error is dropped. Maybe this person doesn't care, but like it's not obvious that that error is there. Question. Yes. Yeah. No, mine's not. We would defer. I guess maybe it has like some. It's also a closure, and it would. I guess that would be like having that. Yeah. What? If someone stops. Would it look something like this? Okay, so this is like we've encountered all these problems trying to handle errors with iterators. Uh, the best thing I could figure out here for like cleaning up after an iterator is basically this. So now our commits function returns two things. It returns an iterator, and then it returns basically a callback, which you call to clean up after the iterator. And then it's that callback that can return an error. So how would this look like if you were consuming this? Basically, you get the iterator and this callback called closer from commits. You iterate over everything, and then at the end, you call this closer to shut everything down, and then you handle the error that comes back from that. You could stick that into a defer. But then this, depending on what the closer does, you start to get into this problem where actually like the question of like, do you call the closer if there was an error that came up during iteration or not is actually quite important. Um, and I don't know if I can quite explain this in full detail very quickly, but I came across this nasty bug while building GitHoo, where basically the difference here of having closer within this error block versus outside of the error block was the difference between like the program just hanging and the program reporting an error. And what was happening is that if we like go back to the previous version where we were trying to handle the error by like yielding it at the very end, implicit in here was the fact that we are returning on line 14 if we encountered an error and never calling wait. But then if you go here, we're always calling wait, even if an error came up in the sequence. And this may not always be a problem, but in my case, because I was waiting for a subprocess, it was a problem. If the error happens, we're like no longer consuming from the output of this subprocess. It's just like waiting, and it's never going to end if you call wait. So the program just hangs. There are many ways you could tackle that. In my case, I realized that I just shouldn't wait for the subprocess if there was an error. But I think the point I'm trying to make here is, okay, we've got this closer, it kind of works. But now previously, everything that was handled in the body of your like iterator function is now split up. And the caller has some responsibility of figuring out, okay, under what conditions should you call closer? Question.
Just, I guess, suggestion, is pass and then cancel.
Yes, I think that's a
That's
good. Yeah, I think having a context, so like in you're saying basically in the body of closer, like we should be canceling the context and just making sure that the subprocess knows to exit. Yeah, that makes sense too. Okay, so I want to wrap up. I have not solved this problem. As you can see, I encountered many issues trying to figure out how to use iterators. Basically, where I ended up with was a function that looks like this. A lot of the initial arguments you can ignore, that's kind of specific to my program. The thing I want to point out is just the return values that I'm returning from this function. Basically, what I ended up with was, okay, I want to handle these 3 different kinds of errors. I want to handle the error that might happen when you're like setting up the iteration. I want to handle errors that might happen during the iteration. And then finally, I want to handle these errors that might come up after the iteration. Most of these errors have to do with like managing the lifetime of the underlying subprocess. So if you're using an iterator to do something more simple, this may not be a problem, but in my case, I was trying to do quite a lot. And it's kind of a bummer that it's like a lot to look at. And it seems strange that handling errors requires these 3 different return values. Um, One possible solution, I think if I were to go back and do this again, maybe there just needs to be like another container, another level of abstraction, where basically the lifetime of the subprocess is kind of managed separately. And then you have some other way to create an iterator over the commits. One strange thing about this though is like you can only consume the commits once. The subprocess is only going to produce commits once. So like calling all a second time doesn't really make sense. So I don't know if this is like completely perfect either, but it might be better than what I had before. So all this is to say, this seems really hard. I haven't figured out a good way to handle errors with iterators. Doesn't seem like there's any official guidance. I'd be very interested to hear if anybody else has done this or figured out a way to do it. But it's not obvious to me how you're supposed to do it. Questions?
I'm surprised that when they did this, they closer to what they do like row iterators. I was still expecting that to be like the final solution. But one thing I was thinking, I think this is kind of gross, but I think it would be very simple. Is for your object, it's just having like like hold on there. Like it simplifies like the searching for the error, allows you to take advantage of built-in. That's kind of gross because it feels like hitting an API that has like error true.
Right.
So, but I don't know. I kind of hate this API now. It doesn't feel very like Go-like. It feels like there's not very clear. One of the things like people complain about most, but I think a lot of people like is how explicit error handling is, and now it's very not explicit.
Yeah, for sure. I don't know too much about the SQL library, but maybe it's similar to the like scanner for like buffered reads from a file or something. And I know that like you call scan, but then there's this error method that you can check to see if an error was produced. Maybe something like that makes more sense. Yeah.
And there's no way to return like a, no way to think that could take that accepts that yield, like it has to be a.
Yeah.
So, well, let's go back to the slide. Yeah. And the error. The, I mean, the thing that you're. So here you point. Really want to do is call sequence. Rather than a line 6 interface. And that interface is what result. There's two concrete implementations. The happy result and that result. Now you're just returning the result. And the consumer knows what to do with it.
I think that's basically exactly how it's implemented in Rust. Like the Rust has this option type, or sorry, the result type, and it's something very similar to that.
So code isn't.
Right.
But the way to, there's a bunch of different ways you can. But typically, we'll have interface. Which, like a text. Like case 1, blah, 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 case 2, whatever. Whatever it is that you're supposed to do.
Yeah.
Print a log and the set result.
I think that's a good alternative to this like sequence 2 thing, and probably allows you to work better. It would work better with the standard library. I think you still have this problem of like the cleanup error. Like, how do you address that? Would you yield like a final element like we were doing before? Or would you have this additional callback? Yeah.
I had apologies that I bring this to you. I had one of the worst PR reviews I've ever gotten. Terrible day.
Oh no.
Documentation on what there's some function use sec2 and expect it to be very specific way. So if you use it this way, you'll actually break anything. Expect it. Because sec2, it says you actually kind of have here
With the K and the V, yeah.
It's for anything with that index. So anything you're reaching over that you could expect. That is the intended purpose. I was asked to refactor my code to get rid of all of my sec2s since I assume the same for you. Iterating through something occasionally, just error. Sec2 seems like the perfect good condition, bad condition. Here's what the Go people said. Sec2 is. And the documentation is. And the result was something like what we a custom object that you're returning sometimes has your good result, sometimes has your bad result.
That's very useful to know, because certainly when you like Google error handling iterators, like the first Reddit result is just use iter sec2. So that's
it's so obviously wanting.
Yeah.
Build for that purpose.
Yes. Yes.
So clear.
Any other? Yeah.
Fundamentally wrong with our code.
Makes sense.
For our purposes, iterators were exactly what we needed. Main thing about iterator is that proceeds when the caller calls it. So if you hit one page and process it, iterators are use case. But it just depends on your use case. Have something that's like IO bound like that, iterators. So an easy pattern. I see. State name flow the whole damn column. That takes forever. I like these speed bound have it, and then they write a photo. They read through the slice of they then so a cursor is just a way of moving. Here's about the end. May have been read on the latest. So that's where like this like the let's see. So then you can start chaining. To load all to
Any last questions? Okay. Thank you all so much for your attention and time.